Hello, I am Aloysius Tiobudi from BINUS University Graduate Program Master of Industrial Engineering. This time we'll discuss a paper titled Discrete Event Simulation Applied to Single Queue Management, a case study at a bank agency, written by Marcos Aurelio Daroja Nascimento et al. From Federal Institute of Education, Science and Technology, Brazil. Introduction. Due to the rise of internet services, the number of online services available to Brazilian banks has grown, with more people using smartphones and computers for internet banking. Bank agencies and branches have decreased due to technological development, leading to more customers but fewer employees. Brazilian government has imposed severe fines and sanctions on banks to prevent queue times from exceeding 15 minutes. So queuing system monitors were adopted to address these issues, but time overflows still occur frequently. So this paper investigates single queuing management through discrete event simulation using Arena software to improve customer service, offering options for banks to consider in designing operator services. Simulation concept. So we need to have a system, a group of elements with unique function linked by interaction and interdependencies, an entity, important object within the system that has characteristic of an entity or that we call attribute, and then activities, action that consume time to be processed, and system state or group of variables describing the system at a given time, and event, action that change the system status. By simulation, we can predict result and reducing decision error while measuring system performance and optimizing resource allocation. But it is time consuming and then needs a complex technical process and specialized hardware and software. Some queue method that we use normally is FIFO, first in first out, LIFO, last in first out, and priority based. And the step, we need to define system objective, creating model and collecting data, and building a computational model, then validating the model, analyzing the result. This research is application in banking on queuing management that is crucial for providing efficient customer service. The research is centered around the challenges faced by bank branches in managing customer queues efficiently, like decreasing number of bank units, and there are government regulation that has imposed strict regulation and fines on banks to ensure the customer do not wait in queues for more than 15 minutes. And customer satisfaction, that is the need to improve customer satisfaction by reducing waiting time and managing queues more effectively, and necessity to utilize bank employees efficiently to achieve service excellence and comply with regulation. The research is using discrete event simulation with Arena software. Research methodology. So data collection are taken from 115 customers on arrival and service times at Sao Paulo, Brazil. Simulation model was then built on Arena software with model design, component of inter-arrival and service time distribution, and model parameter components, number of operators, performance metrics. Scenario tested on different number of operators, 9, 10, 11, 12, and 13. The metrics, customer serve, waiting time, queue length, operator utilization. This is the model. So we have arrival as the input, and then the process, this is the service, and then the exit. Data collected from customers were then tested to identify which distribution would best fit the data. So this is the data, inter-arrival times, and then service times. And the researcher used the input analyzer of Arena to perform distribution fit. So the best distribution fitted was gamma. And then the researcher built the model on Arena. Simulation is performed by 100 replication by changing the number of operators to verify the change in number of customer out of the system. Waiting time in queue, queue length, and utilization. And this is the result. We can see with 9 operators, the system was highly utilized, 98%, meaning the operators were almost always busy. However, the high utilization led to long waiting times, 38 minutes, and a large queue, 36 people, indicating that the system was overburdened and inefficient in terms of customer service. So while with 11 operators, the utilization was slightly lower, but the system achieved a balance between operator workload and customer service efficiency. The waiting time and queue length were significantly reduced to 12 minutes and 12 people, making the system more efficient and compliant with local legislation. While we can see the lower utilization of 13 people, 13 operator, the utilization dropped further, indicating operators were less busy and minimal waiting times and very short queues of only 2 people. It also meant that the system was underutilized, potentially leading to a higher operational costs without a proportional increase in efficiency. Optimal utilization is 11 operators for best balance, but the trade-off is cost versus efficiency with more operators. In summary, the study found that optimal numbers provided the best balance between high utilization and efficient customer service, making the system both effective and compliant with local regulation. This balance is crucial for maintaining both operational efficiency and customer satisfaction. Alternative solution is training employees to reduce service times that could maintain efficiency with fewer operators. And then we can see the importance of simulation that is a valuable tool for managing queues and decision making in banking. Okay, thank you, Prof.